Sparkane has a little challenge for us. He wants to see if we can use our knowledge of perspective to solve a little puzzle. I'm not a flat earther, but I do know how perspective works. So we have a camera some unknown distance away from a white ball, and the white ball is some unknown size. That's what we'll be trying to solve. What does he give us to work with? Well, we've got the ball, the camera's looking at the ball, and he brings in a ruler at a known distance away. He tells us the ruler is 128.6 centimeters from the camera. And based on that, we can look at the ball and we can get an estimate of the size, the apparent size of the ball, compared to this ruler at this known distance. And then the next thing he does is he slides the camera over 150 centimeters, and from there we can still see the ball. So based on that video, we are asked to reconstruct the circumference of the ball and the ball's distance from the camera. So to make things easier, let me just take that same diagram and draw it again from the perspective of the camera. So now when the camera moves, the camera's perspective makes it look like the ball moves, right? So in the video, what we see is the ball moving in the opposite direction. Okay, so that's what that'll look like. And if we just complete this little triangle here, that's what we're looking for, is this length here, and what we've got is that. Now don't forget we have that ruler that was provided, and that's going to be absolutely key. Create a triangle. I create the red triangle, which represents the motion of the ball as the backside of the triangle, and this unknown length here is the height of that triangle. But if we look here, we have a similar triangle, that is a triangle with the exact same angles, and that would be the length of that side on the ruler. Now we know this distance, it was given to us, and so because of that, we're going to be able to work this out using what's called similar triangles. Okay, dropping out the art and just leaving the triangles. We can measure using the ruler how long this side of the green triangle is. And what we're searching for is the big unknown D, which is how tall the red triangle is. Since there's similar triangles, that means the ratio of this length to its base is the same as the green triangle's length to its base. And so I've written that here. D is the big unknown, and the base was 150 centimeters. He told us how far he moved the camera. And the length of the green triangle is given as 128.6, and L, I think we can measure that if we just go to the video. Okay, so I don't have the original source video or anything. I just pulled this down off of YouTube, and that's going to make the quality suffer a little bit. But yeah, we'll work with what we got. We should get a pretty decent estimate. So we start off with the ball at some unknown distance, and then we look down at the ruler. So we got that shot, we got the ball shot, and then we move the camera over a little bit and we'll get the third position. So what have I done? I just loaded these in, as you can see here, as separate layers, and this is just GIMP. This is free. This is free software. So what have I done here? I'm going to mask out the ball. I just want to show only the ball against the background of the ruler, because I'm going to use the ruler for measurements. So let's enable that mask. Where did I put it? Right there. Okay, so that's just showing I haven't moved these shots at all, right? So this is exactly my frame capture. This is exactly where the ball fell on the ruler in that shot. Now let's do the same thing for the ball in the other position. Boom. Okay, here we are. Here's the other ball. There's the ball having moved in the two shots. So what am I going to do next is let's drop a line straight down from each ball from the center of the ball. I marked a particular pixel, right? These darker pixels that are in the center here of the balls identified a particular pixel, and I will drop lines, green lines, straight down so that we can see where they fall on that ruler. And then the pink lines is where I'm estimating the width of that ball to be. We're going to measure that against the ruler as well. I put in some circles here to show, and let's zoom in on that a bit. There we go. Let's show that circle. This is my estimate for what the actual size of the ball is, but you know, when you look close, this is what I'm talking about. Not having the original and having to deal with this, the blurriness of this image. I have to work with that and call that my estimate. Okay. So what do we find? First of all, we're going to need a scale to work with. We're going to need a good scale. I can just try to read the numbers off here, and you can do that. I mean, you can just see where is that here, subtract them, and do the same thing with the purples. That'll work, but I was thinking maybe I could get a better result if I measure the pixels. I'm going to measure the ruler, a large section of the ruler, to maximize my accuracy. So any one pixel here or there is going to change the result. So maximize your accuracy by making that a wide distance. So I don't know if you can read that on the video, but right on the bottom of my screen it should say how wide this rectangle is, and I got 1592. So from the 105 to the 115 on the ruler is 1592 pixels, and that is 10 centimeters. So 10 centimeters is 1592 pixels. How far apart are the greens? The green lines, let's do them next. We got looks like 714 pixels. I'm going to say 714 pixels. And the purple lines, let's get them both on screen here. Okay, the purple lines, how far apart are they? They are 93 pixels apart. So let's crunch the numbers and see what we get. From the video, we were able to determine that 10 centimeters equates to 1592 pixels. And we could measure how long this side was on the ruler at 714 pixels. So using this ratio, let's just convert that to centimeters. We have 4.49. So now we have all of our unknowns except that one, D. Let's solve this equation for D, and there we go. D is approximately 4,300 centimeters. There you go. That's question number 1 answered. Next up, let's get the circumference of the ball. Now, I'm going to measure the diameter of the ball, and from that, I'll calculate the circumference. I'm going to use the exact same technique. The ruler is in front of the ball at a known distance. We now know the distance to the ball. What we're looking for is, I'm calling it the width of the ball because I already used D for distance. So width of the ball, and if we make our little similar triangles on our ruler, here we go again. The exact same formula can be used again, which is that the ratio of this width to its distance is the same as this width to its distance. Just wrote that out there. From the video we had 1592 pixels is 10 centimeters from before. Let's take a look at how wide the ball is against the ruler on the video. They are 93 pixels apart. All right, I measured that at 93 pixels, which comes out to 0.584 centimeters, and that's the apparent width of it. That's just the width against the ruler. So what is the width in the background? We'll use this formula and we'll get 19.5 centimeters. From that, very easily we can get the circumference just by multiplying by pi, and we get 61.3 centimeters. So My estimates for the distance from the camera to the ball is 43 meters. And my estimate for the circumference of the ball is 61.3 centimeters.